This is SpaceTime Series 27, Episode 56, for broadcast on the 8th of May, 2024. Coming up on SpaceTime, new evidence of how geysers erupt on the Saturnian ice moon Enceladus, NASA scientists gearing up for solar storms on Mars, and confirmation it was space junk which slammed into a Florida home last month. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Garry.
A new study suggests that the spectacular geysers erupting from the Saturnian ice moon Enceladus' South Pole tiger stripes are caused by the same process which triggers California's San Andreas Fault. Over the course of its elliptical orbit, Enceladus is squeezed unevenly by Saturn's gravitational pull, causing the tiny moon to deform from a spherical shape to an almost football-like shape and then back again. This continuous cyclic stress causes a phenomenon within Enceladus known as tidal heating, and it generates enough energy to maintain what's believed to be a global subsurface ocean deep beneath the icy Enceladine crust. At Enceladus' south pole, where it's thought the ice is the thinnest, a large number of jets spray icy water particles out into space from a set of jagged 150-kilometer-long fault lines known as tiger stripes. And this ejected material then coalesces above the moon's surface to form a plume or geyser. Samples of this plume material, analyzed by NASA's Cassini mission, suggest that the chemical conditions believed to be necessary for life may well exist in the ocean deep beneath Enceladus' surface. Now, new research led by Alexander Byrne and Mark Simons from Caltech has developed a detailed geophysical model which characterizes the motion of these tiger stripe fault lines and provides new insights into the geological processes controlling the geyser activity. The plume above Enceladus' south pole varies in intensity, waxing and waning in strength over time to produce two notable bright peaks in emission during the moon's 33-hour orbit around Saturn. Now, it's long been theorized that tidal forces cause the tiger stripe fault lines to open and close, sort of like elevator doors, allowing them to emit more or less material in cycles that correspond to those tides. However, there's a problem here. They don't accurately predict the timing of the peaks in the plume brightness. More problematic, the fault opening mechanism actually requires more energy than what's expected to be available from tidal flexing alone. The new research, reported in the journal Nature Geoscience, suggests that observed variations in Enceladus' plume strength may be due to the tiger stripe faults moving in a strike-slip fashion, with one side shearing past the other, similar to the style of fault motion that produce earthquakes along faults like California's San Andreas. The energy required for such fault motion is considerably less than that required by the opening-closing mechanism. To support their hypothesis, Byrne and Simons developed a sophisticated numerical model to simulate strike-slip motion along Enceladus' faults. These models also consider the role of friction between the fault's icy walls, which causes deformation to be sensitive to both compressional stresses that tend to clamp and unclamp the fault and shear stresses that tend to drive slip on the fault. The good news is the numerical model was able to simulate slip along the tiger stripes in a manner which matches the variations in plume brightness as well as spatial variations in the surface temperature, suggesting that the jets are indeed controlled by a strike-slip motion over Enceladus' orbit. The researchers theorized that the individual jets occur at pull-aparts in the faults, bent sections in the fault that open under regional strike-slip motion. Now, recent separate research by scientists at NASA's Jet Propulsion Laboratory also examined the tiger stripe region and found geological evidence for pull-aparts along the faults, and it was located right at the location of the jets. Back in 2005, the Cassini mission flew by Enceladus, sampling jet material, and discovered that the plumes contain elements like carbon and nitrogen. That indicates that the subsurface ocean could currently harbor conditions suitable for life. In addition to the presence of these and other chemical components, key geophysical conditions such as sufficient heat production and nutrient flux between the core of the ocean and the surface are required for habitability. Simon says for life to evolve, conditions for habitability have to be just right for a long time, not just an instant. On Enceladus, you would need a long-lived ocean. Geophysical and geological observations can provide key constraints on the dynamics of the core and the crust, as well as the extent to which these processes have been active over time. Burns says some detailed measurements of motion along the target stripes are now needed to confirm the hypothesis. For instance, scientists can now image fault slips such as earthquakes on Earth using radar measurements from orbiting satellites. And applying these same methods at Enceladus would allow scientists to better understand the transport of material from the ocean to the surface, the thickness of the ice crust itself, and the long-term conditions which may enable life to form and maybe even evolve on Enceladus. Now, the thing you've got to remember about life is that if we find life on Mars, well, that's a big deal. But the Earth and Mars have been swapping rocks for billions of years, and consequently, any evidence of life we find on Mars could have originated on Earth. Or, on the other hand, we might all be Martians, with life starting on Mars and then being thrown to Earth by some asteroid impact. But in the outer solar system, on icy moons like Europa or Saturn's Enceladus, where there's a huge, thick, icy barrier between space and what's happening below the crust, well, if life develops there, then it could be anywhere. And that's an amazing possibility. This is space-time. Still to come, NASA astronauts gearing up for solar storms on Mars, and confirmation that space junk slammed into a home in Florida. All that and more still to come on SpaceTime. As our sun's activity continues to ramp up as it approaches solar max, the climax of its 11-year solar cycle, scientists with NASA are preparing to observe how the increase in solar storms and radiation will affect equipment and possibly in the future humans on the red planet Mars. Now, during solar maximum, the sun's especially prone to throwing off fiery tantrums. These include solar flares and coronal mass ejections, which can launch plasma and radiation deep into space. When these solar events erupt, they're known as solar or geomagnetic storms. Now, Earth's magnetic field helps shield this planet from the many effects of these storms. Some, however, do get through, damaging or destroying satellites, affecting navigation and communication systems, and even causing blackouts on the planet's surface. They also pose a threat to astronauts orbiting the planet and even people in high-flying aircraft. And of course, they also cause the spectacular northern and southern lights, the aurora borealis and aurora australis, which have been on display over the last few weeks. But Mars is a very different case. See, the red planet lost its global magnetic field long ago. That leaves it more vulnerable to the sun's energetic particles. Now, in the months and years ahead, depending on exactly how long it takes to reach solar maxima, 2 of NASA's Mars spacecraft will have an unprecedented opportunity to study just how this intense solar activity affects the red planet. And that's important to know, because before sending people to Mars, space agencies need to determine, among other things, just what kind of radiation protection they'll need. Shannon Curry from the University of Colorado Boulder is the principal scientist for NASA's Mars Atmosphere and Volatile Evolution spacecraft, MAVEN. She says we don't have a solid handle on what effects radiation is likely to have on humans and assets on the Martian surface. So, when a large space weather event hits Mars, she wants to be able to study and understand the solar radiation better before astronauts go there. MAVEN's operated by NASA's Goddard Space Flight Center in Greenbelt, Maryland. It observes radiation and solar particles from high orbit above the Martian surface. The planet's thin atmosphere can affect the intensity of particles by the time they reach the surface, which is where NASA's Mars Curiosity rover in Gale Crater comes in. Data from Curiosity's radiation assessment detector will help scientists understand how radiation breaks down carbon-based molecules on the Martian surface, a process that could be affecting whether or not signs of ancient microbial life are even present on Mars. The car-sized 6-wheeled rover has also been providing NASA with an idea of just how much shielding from radiation astronauts could expect by using caves or lava tubes or even cliff faces for protection. When a solar event occurs, scientists look both at the quantity of the solar particles and also how energetic they are. So you can have 1 million particles with very low energy or just 10 extremely high energy particles. While Maven's instruments are more sensitive to low-energy ones, Curiosity's got the only instrument capable of seeing high-energy ones, which make it through the atmosphere down to the surface. When Maven detects a big solar flare, the Orbiter's team lets the Curiosity team know about it so they can watch for changes in the data. The two missions can even assemble a time series measuring changes down to the half second as particles arrive in the Martian atmosphere, interact with it, and then eventually strike the surface down below. The Maven mission also leads an early warning system that lets other Martian spacecraft know that the radiation levels are about to rise. This heads up enables mission scientists to turn off instruments that could be vulnerable to solar flares and radiation, which can interfere with system electronics and communications. Beyond helping to keep astronauts and spacecraft safe, studying solar maxima on Mars will also provide new insights into why Mars changed from being a warm, wet world with an Earth-like environment capable of harboring life billions of years ago to the freeze-dried desert it's become today. Now, right now, Mars is at a point in its orbit where it's closest to the Sun, which heats up the atmosphere. That can cause billowing dust storms to blanket the surface. Sometimes these storms merge and become global. While there's little water left on Mars, most of it is in the form of ice under the surface, and especially at the poles. But some still circulates as vapor in the atmosphere. Now, scientists have long wondered whether global dust storms help eject this water vapor, lofting it high above the planet where the atmosphere is getting stripped away by the constant erosion of solar winds and storms. Now, one theory is that this process, repeated enough times over eons, might explain how Mars went from having lakes and rivers to having virtually no surface water today. And if a global dust storm were to occur at the same time as a solar storm, it would provide a great opportunity to test that theory. Curry says scientists are especially excited because this particular solar maxima is happening at the start of the dustiest season on Mars. But they also know that a global dust storm is a fairly rare occurrence.
This is a big year for NASA's Maven orbiter. What it could learn could someday help future astronauts safely land on Mars and provide us with a new view of the Sun. 10 years ago, we sent Maven to Mars to measure space weather and how it interacts with the upper atmosphere. This includes solar flares, which are giant explosions on the Sun, which send radiation into space. Every 11 years, the Sun goes through cycles of activity. This year, we've seen more space weather than we ever have during the entire mission. And while solar flares can occur at any time, they occur more frequently and more intensely at the peak of this cycle called solar maximum. Right now, we're almost at that peak, and I'm really excited about what solar flares can teach us about the red planet. Maven is one of 2 missions studying radiation at Mars. The orbiter is able to observe many phenomena from the Sun, including radiation, high-energy particles, and magnetic fields. Maven can also see stunning auroras from its vantage point high above the planet, which future astronauts might be able to see someday. Meanwhile, down on the surface of Mars, the Curiosity rover has a radiation detector called RAD. It studies high-energy particles that get all the way through the atmosphere and down to the surface. Together, Maven and Curiosity give us a better understanding of the radiation environment at Mars. Studying how intense solar flares can get during solar maximum can help NASA develop protection for future astronauts, robots, and spacecraft. There's another advantage to studying the Sun from Mars. Here on Earth, we can only see one side of the Sun, but when Maven is on the other side, it can spot activity coming days before we can. On a personal note, Maven is my spacecraft baby, and I am so excited about observing the next few years of solar flares, space weather, and the atmosphere of Mars.
That's Shannon Curry from the University of Colorado Boulder and principal scientist for NASA's Mars Atmosphere and Volatile Evolution spacecraft, Maven. And this is SpaceTime. Still to come, scientists confirm that space junk slammed into a Florida home last month. And later in the science report, a new study confirms that teens who spend too much time online are more likely to skip school. All that and more still to come on SpaceTime. NASA has confirmed that an object which crashed into a Florida home last month was a chunk of space junk jettisoned from the International Space Station. The debris was composed of the metallic alloy Inconel. It was around 10 centimeters long and had a mass of about 0.7 kilograms. The object was originally part of the EP-9 cargo pallet containing a stanchion support used to mount old batteries which had been released from the orbiting outpost during a spacewalk back in 2021. Now, mission managers had been tracking it ever since, watching its orbit slowly decay. Now, it should have burnt up during atmospheric re-entry, but instead it survived, eventually smashing through the roof and 2 floors of a Naples home. The trajectory of the space junk closely matched the official predictions for the atmospheric burn-up of the cargo pallet fragment. NASA says it's still investigating how the debris survived atmospheric re-entry, and they'll update its engineering models accordingly. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research warns that older adults who begin losing their sense of smell could be more likely to also lose their mobility faster. A report in the Journal of the American Medical Association tested the sense of smell of 2,500 people aged between 70 and 79. And they then tested their walking speed on multiple occasions over the next 7 years. What they found was fascinating. Those with a reduced ability to smell also tended to walk slower during their first test, and their walking speed declined faster over the coming years compared to those without an impaired sense of smell. The researchers say that this shows the loss of sense of smell could be a sign that a person is also losing their mobility, but more research will be needed in order to understand exactly why this link exists. Scientists have developed a self-digesting plastic which they say could not only help reduce plastic pollution, but also strengthen the plastic itself. A report in the journal Nature Communications claims researchers developed a biodegradable version of the commercial plastic polyurethane, which is often used for phone cases, footwear and car parts, but currently has no recycling stream, and so it mostly ends up in landfill. The team embedded spores of a plastic-degrading bacteria, Bacillus subtilis, and genetically engineered the bacteria to tolerate the extreme heat needed to produce the plastic. Upon disposal in a simulated environment, rapid biodegradation of the plastic was triggered by exposure to certain nutrients in the compost. The authors found that spore incorporation led to more than 90% of plastic degradation within 5 months. And amazingly, it also increased the toughness of the plastic by about 37% compared to thermoplastic polyurethanes without the spores. A new study has found that teens who compulsively spend too much time online and don't get enough sleep or exercise are more likely to skip school or miss classes because of illness, with girls affected by internet addiction more than boys. The findings, reported in the journal Archives of Disease in Childhood, are based on a survey of 86,270 teenagers aged between 14 and 16 who were asked about the time they spent online, their family relationships, their sleep patterns, and their exercise routines. They classified internet usage as an addiction if the teens neglected family, friends, study, eating, or sleeping in order to spend more time online, and if they became anxious when they were offline. Overall, they found that between 3 and 4% frequently miss school. They conclude that excessive internet use is linked to an increased risk of both truancy and illness-related absence, but the effect was reduced by better sleep and more exercise, as well as by better relationships with their parents. And of course, we all know how well kids and parents get on during those teenage years. Apple's announcing its new iPads, including a new iPad Pro, a larger iPad Air, and new Magic Keyboard and Apple Pencil. Now, importantly, the new iPad Pro will feature the never-before-seen M4 chip, which is powerful enough to handle many AI capabilities on device rather than in the cloud. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
This week, everyone will be talking about the new iPads, and they're meant to come with the M4 chips, or at least the iPad Pro models anyway, with the expectation that they will do generative AI on device. Now, this was all supposed to be announced at the Worldwide Developer Conference, but because Microsoft is launching its new Snapdragon M4-powered ARM laptops later this month. Those laptops are said to be as fast as the M3. Obviously, Apple wants to be right up the front there with its newest Pro devices. Now, it's also going to have the iPad Air, and it will have a 12.9-inch Air. So this is a larger but cheaper iPad for those who don't want to spend the premium dollars for the M4-powered iPad Pro. There's also meant to be a third-generation Apple Pencil, which will not only be squeezable, but it'll have haptic feedback. So we're yet to see what all this means, and we're yet to see how much generative AI is being done on device. But the new iPads, which were rumored to come late last year and then rumored to come in February or March, they've been officially announced to come on in the US May the 7th, which is May the 8th in Australia. And by the time people are listening to this podcast, it will be all over the news. All the details will be confirmed, but they should be very exciting iPads. And Apple's throwing down the gauntlet to the rest of the industry who have finally caught up with ARM-powered chips that can run Windows with the same super long battery life, no need for a cooling fan, the same sort of benefits that Apple had already back in 2020. The Windows world is caught up, but Apple is already striving ahead with better chips. And later this year, we'll have the MacBook Airs and the Pros with the M4, and we'll have the new iPhones as well. But big excitement for what Apple is going to launch. And by the time you hear this, it should all be official.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Garry.
You've been listening to SpaceTime with Stuart Garry. This has been another quality podcast production from Bytes.com.